longer. So this is the weight of a diamond, a round cut diamond. And I guess it's easier to measure the diameter than it is to actually weigh it. Like, I don't know if the scale that can measure something so light as a diamond is really expensive or what, but if you know how far across it is, you plug it in here and it'll tell you the weight of it. So W is the weight in carats. Who thought carats was spelled with a K? Like 14 karat gold when you're looking at necklaces. Did you guys think that? Isn't it with a K? I just had to Google it in first period. They say it's interchangeable, but with a K, it's almost always gold. And with a C, they're talking about gems, diamonds, emeralds, sapphires. I don't know. I can show you that. You can Google it though. So carats with a C. D is the diameter in millimeters. So 12 millimeters is a lot. We're talking about a pretty big diamond here. According to the model, what is the weight of a diamond with a diameter of 12? So we're just plugging in. Put 12 in here, 12 in here, and 12 in here. This is a lot about being very careful and deliberate with your calculator. This is about data entry. Are you getting your decimals right? Are you getting your signs right? Are you doing precise work? No, just plug in. They're already telling you what it is. They're telling you what, yeah. Plug in 12 and get the answer. Oh, this like number 3 here, the mathematical thinking where you can complete tasks with mathematical fluency. Some of that is just like being careful. Like you have a lot of numbers to put in. Put it in your calculator. Are you gonna get the right number out the first time? A lot of data entry careers out there. Yeah. I would put parentheses 12 and then a 3. I use parentheses, not a multiplication sign. So, yeah, only goes to the 12. So ideally, you're putting all of this in at once in your calculator. You're not going to keep writing down numbers and going back and redoing it. You're going to be really careful about putting it all in at once and hit enter. And I double check. I write a problem down. I double check. Did I get all the zeros? Did I put the minus signs? Okay, and then I start putting it in. And when I put it in, I'm slow and careful because I want to make sure I do it right. Mathematical fluency. Are we getting our numbers right? We're being careful. Good job. These I'm gonna put a subtraction sign in, and it's not the same. And then I'm annoyed because this book doesn't tell you exactly right around, so I'm gonna go ahead. I'm gonna say round to the 1,000, and that means 3 decimal places. And we have to talk more about this precise too. How to precisely round for digital math. I want 3 decimals. So. A diamond with diameter 12 millimeters. Why aren't they calling you guys? Oh, you're working missing it? I'm gonna call and share it right now, just make sure. Right? Yeah. Alright, you guys. So what our assignment looks like today, it says odds in class, evens for homework. So these problems are paired up. It's 5 and 6, and I'm gonna do 5, and then you're gonna model number 6 just like I did 5, and then it's 9 and 10. I'm gonna do 9 for you. You're gonna write some notes as I do it, and then you're gonna do 10. I'm gonna do 13, and then you're gonna do 14. I'm gonna do 17. You're gonna do 20. I'm gonna do 21. You're gonna do 35. Okay. All right, let's go. Now Friday we ran out of time. What's your language? Professional environment. Okay. When we look at Friday ran out of time, and I told you to shorten your assignment, I believe, second period. So everybody go to page 305 so I can just introduce you to some vocabulary. Polynomial vocabulary. Hopefully you read a little bit. There's certain rules about whether or not something can be a polynomial. Let's go to 305 to start. Let's start at 305. That's what I thought you were saying before. So the first thing it says, is this a polynomial, yes or no? So out of these 3 questions, only the middle one is a no. Yes, polynomial, no polynomial, yes, polynomial. What's happening in number 2 that means it can't be called negative exponent? Negative exponent means we're not looking at a polynomial. So we just finished a whole chapter and everything was x squared. X squared, x squared, x squared. Those are called quadratics. This whole chapter is emphasizing that x could be much higher than just x squared, like this is to the 3rd. So we're going to be looking at higher degree expressions and equations, and so we don't call them quadratics, we call them polynomials. Okay. So first off, it says to put it in order. So standard form puts the highest exponent first. So this was given out of order. Always go put the highest exponent first. This one we don't have to do. This is out of order. The x to the 4th was last. It should go first. So I put it in order here. This should be 3x to the 4th. X to the 3rd minus 6x. The degree, if you read, the degree is the highest exponent. So this is a degree 2, and this one is a degree 4. Degree means highest exponent. Leading coefficient is just the number in front. The number in front of this one is negative 1.6. The number in front of this one is 3. Louis, is the 3 in front? Nobody learned it. This is our first time talking about it. So look at it. Why did I say the leading coefficient is 3? Yep, so leading coefficient. This is the one that most people will end up asking about. That just means the number in front. So, it's the number in front when the problem is in order, specifically when the problem is in order. Right now, as the problem is typed in black ink by the textbook, the number in front is an invisible 1. But it wasn't typed in the right order. I put it in the right order with x to the 4th first. So this one, the number in front would be 3 based on the standard form. So, I told you Friday to read the section and try these problems. I hope you did. There's a lot of vocabulary here. When you look at number 4, which one is not a polynomial? Yes, polynomial. What's the degree of this one? 5. Degree 5 is the highest exponent. What's the leading coefficient, Kalia? What's the leading coefficient of this one? I'll zoom it. Leading coefficient. 7. Degree 5. Good job. Okay. What's the degree of this one? Miley, are you in it? 3. The leading nope, it's actually 8. We're gonna put this in front. So that one's out of order. This would be negative 2x to the 8 plus 3x to the 4 plus 3/4. So they're gonna try to trick you and give it to you out of order. You gotta put it in the right order. The degree is 8. The leading coefficient is negative 2. You reorder it before you answer. That's a good one to write down. So yeah, I flipped the page to page 306. The question is, which one doesn't belong? And the truth is, this one doesn't belong. And the reason that one doesn't belong is because of the negative exponent. This is not a polynomial. Because x has a negative exponent. So because it's not even a polynomial, it breaks that rule. We don't have to put it in order. We won't talk about degree, nothing like that. This one's okay. The leading coefficient is 8 and the degree is 4. Questions? All right, moving on. Head to page 325. Let's start some work for today. We were supposed to do the bower quiz, but if the juniors are leaving here soon, I'd rather do the work with you. Yeah, I would say maybe it's canceled at this point. Couple more minutes. You know? Yeah, on Friday. No, that was just for you. So you can get that 100. Again. Maybe I should. All right, here we go. I'm going to do number 5. Number 5 is combining like terms. Well, no. Plus signs don't change anything. That's like multiplying by negative or by positive 1. Like, but still, it's just times 1. It'll stay the same. Okay, here's the pages you're ripping out if you did not rip out on Friday. 299. Yeah. Okay. So the main thing I want to say about adding. Add coefficients. This is the important part. The exponents do not change. So if you're going to make a note at home for this one, make a note. When you're adding coefficients, your exponents do not change. Okay? This is a lot. This is a lot of numbers, so I very deliberately cross things out as I go. So I'm going to start with highest exponent, so I'm in order. My highest exponent is 7x to the 6th.
Teacher, please find the direction. At this time, please release all 11th graders to report to the auditorium. Again, please release all 11th graders to report to the auditorium. If you have all 11th graders, please accompany your students. Thank you.
Is it about this one? Number 5? Okay, what's your question? Just do the problem. Alright, now we'll do the x to the 5th. 2x to the 5th and 5x to the 5th is going to give 7x to the 5th. The exponent did not change. I'm crossing them out because all the time I do these long problems and I forget one. All the time. And now I'll do x to the 4th. None x's to the 4th. So I'll look for x to the 3rd. Just one x to the 3rd. Now I'm going to do the squares. I got a negative 3x squared, negative 6x squared. So negative 3 minus 6, negative 9, x squared. Exponent does not change. Cross them out. I did it. Now I'll do the x's. 9x and 2x. Add those together to get 11x. I'll cross them out. And I see all I have left is a minus 5. This is a 6-degree polynomial because the highest exponent is 6. The LC, the leading coefficient, is 7. So the sum resulted in a 6-degree polynomial with a leading coefficient of 7. Combining like terms, there's just a lot of them to combine. So it's really about being organized and careful. Yeah. Which the LC? Leading coefficient. That just means the number in front when it's in order. So the number in front is 7. That's called a degree, and that's called the leading coefficient. Now, I'll give you a heads up. The reason we're talking about leading coefficients is because we're looking towards graphing these things. And so we'll talk about, is the leading coefficient positive or negative? Because if it's positive, you're picturing a positive graph versus a negative graph. And then degree, also, we'll talk about what degree is it? So what does that picture look like? What does the degree of 6 look like? So the reason we're talking about this vocabulary is because we have to start identifying these graphs, these big problems. All right, so that's number 5. Any more questions on 5? Yeah, reduce the fraction. I'm going to head over to number 9. So 9 is also combining like terms, but since there's a minus sign, you're going to multiply each one of these by -1. You're going to change all of their signs, and then you're going to combine. Swap signs. No, you should have them all done. So I rewrite the whole problem. Like if I want to get it 100% correct, I'm careful. I take my time. I'm going to write it out. Rewrite the whole problem. That'll be a -7x to the 5th. This is a -1 times a -8. That'll be a +8. -1 times a +2. -1 times -11. So we practice this with complex numbers. A plus BI. Last chapter. Now it's just long. Okay. And now combine like terms. I got 5x to the 6th first. Then I'll look for any to the 5th. I do have a x to the 5th problem, or term I should say. I cross it out as soon as I write it, because if I don't, I'll miss some. Now x to the 4th, -2x to the 4th, 8x to the 4th. Cross those out. 9x to the 3rd. Cross that one out. I'll look for x squared. Not x squared. Okay. X to the 1st. A +2x, -2x cancel. And my last thing to combine, -4, +11. Is what? I don't know. You're going to shorten it somehow? No, it says find the difference. The directions here. What page are you on? I'm on page 25. No, we've moved past that, just identifying, and now we're adding, subtracting, and multiplying. Janine, what did you get for number 9? Plus 7. Right, we have to plug all of these. Like, Or do we just leave it like that? We leave it like that. That's the answer.
Wait, when you find this empty, you still need to find the whole thing. Or just,
This is the answer. This is how we do it. Yep, that's the answer. No, the answer that I boxed is the answer. Not over there. That's just vocabulary. Jaheim, do you not have the questions? Like, what are you doing with your phone?
I'm done with those.
Okay, just put your phone down, okay? Like, you want me to write the numbers up here, and then you won't look at your phone? Just put your phone away. 5, 6, 9, 10, 13. All right, I'm gonna do 13 next. Let's go to 13. This is how a classroom's supposed to be. How many people are in here? 17.
Why didn't they schedule change?
That's fine. Teachers change. That's what they said. Teachers left. Teachers came back.
They just spoke of the change.
No. So the original schedule changes is because some teachers volunteered to teach 7 classes to reduce class sizes. And now? So, and before they were only teaching 6. So where kids removed was previously an empty period. So they're trying to reduce class sizes.
Both of my classes were full.
They got moved into?
No, the old class, my whole second period was half.
It's back. And now you're in class?
How long before next period?
Oh, really? And none of your teachers changed?
No, they just switched the period. Very exciting.
It's the same teacher?
They just switched it around. My 4th and 6th period.
The same teacher, same class?
Twice. Originally it was John Succeed and Sam. And they swapped it to Miss Ed John Succeed. Now they switching it around.
I don't know what that is. Alright, multiply. Let's make a big note over numbers 13 through 20. Write this down. As soon as you transition into multiply, you have to add exponents. So up until this point, we're combining like terms, we're adding the numbers in front, we're keeping exponents the same. All of a sudden, you start multiplying, boom, exponents have to change. It's that transition that I start to lose students. Because we're going to start distributing a lot here in this section. So 7x to the third times 5x squared. I distribute that. X to the fifth. Yep. Add your exponents. That'll make 5 of them. 7x to the third times 3x. What I do is the x doesn't have an exponent visible. There is a 1 there. I write the 1 in so I don't mess it up. 21x to the fourth. But sometimes students will forget to add the 1 in if you don't write it. And then 7x to the third just stays. They're all positive. Box it. That's done. Okay, any questions on that one? Yes, you can drop that. Well, I don't know, but with a 5th degree, you can have 4 zeros, 4x intercepts. And anytime the exponent's odd, it'll start low and it'll end high. So I know it looks something like this. I just messed that up. It is curvy like a trig function, but 5 zeros. But I don't know the details until I start really plugging in here in the table. All right, next 17. This is similar to FOIL. but it's a 3 by 3. So you have to distribute everything. So I'm going to, maybe I ignore 2. I distribute the x squared through to the first, the middle, and the last. I ignore these. And then I'm going to write that down, and then I'll ignore the first one and distribute the middle. You distribute 3 times. It's just big time distribution. So x squared times x squared. Again, when we're multiplying, we're adding exponents, so that's x to the 4th. X squared times negative 3x. Negative 3x to the 3rd. Add your exponents. There is a 1 right here that you can't see. X squared times negative 5. Negative 5x. So boop. Go back to the problem. Any questions about our first set of distribution? So now I'm going to white out so I can focus on the middle. Now I do negative 2x times x squared. Negative 2x times negative 3x. And negative 2x times negative 5.
X squared.
Did I mess it up? Yep. Everybody make sure you have an exponent of 2 here. Thank you, Natalie. X squared times negative 5 negative 5x squared. Okay. Now I do it again. Negative 2x times x squared. Negative 2x to the 3rd. Negative 2x times negative 3x. Negative times a negative is a positive. X times x is x squared. Negative 2x times negative 5. Positive 10x. One more round of distribution. Now I'm going to distribute. I'm going to erase all my arrows. And on my last one, negative 4 times all 3. Okay? Negative 4x squared plus 12x plus 20. Now, combine like terms. So go highest to lowest. So x to the 4th is the highest exponent. Yeah. I see 2 terms that are 3rd degree terms. Negative 3x to the 3rd minus 2x to the 3rd negative 5x to the 3rd. Keep in mind, when you combine like terms, you're not changing exponents anymore. It's just when you multiply. I got 3x squareds. I'm going to look across all 3. Negative 5x squared plus 6x squared. That'll be 1. Minus 4. Negative 3. Cross out to stay organized. When I don't cross out, I always mess up. I gotta go slow, I gotta cross out. 10x and 12x, 22x. 20 at the end. Alright, no. No, I'm not. I'm gonna put on Those are called binomials. There's 3 of them. You're going to FOIL 2. You ignore the 3rd one. You fully FOIL 2 while ignoring this one, and then after you're done foiling, then you distribute to that last one. Ignore the 3rd and 4th. Okay. Anyway. 21 first. Alright, we have foiled a lot. So, if you need to put a little paper over it, put a paper. X times x times 2, negative 3. X squared plus 2x minus 3x minus 6. The first FOIL. Combine the middle-like terms as usual. This makes me want to factor. Factoring was our whole thing. Now, so you know, the reason we're doing this is because later in this chapter, we're going to factor. We're going to factor into 3 sets. And then we're going to take our 3 factors, set them equal to 0, and plot them and get like an S-shaped graph. So it's just like last chapter, but more points, more curves, more of everything. Okay, so now I did the 2. I'm going to bring the 3rd one in, which was x plus 4.
We can't just do it all together.
No. I encourage you to try, because I tried, it's way hard to do it all at the same time. You'll end up multiplying too many times into a couple of them. It'll come out too late. My experience. Sometimes you need to try things for yourself. X to the 3rd, 4x squared. Negative x squared minus 4x. Minus 6x. I do have a project I'm giving before Thanksgiving.
What kind of help? I think we should do that. But not.
Wouldn't this be 4x squared?
I was nervous. Somebody doesn't And we're left with a cubic polynomial. Yeah. So, right. So later in the chapter, we're going to give you this, and we're going to tell you to factor it. Okay, so there's a factoring process for this. And then you work backwards to those, set them equal to 0, and start your graph. So that's our end game here, and all this foiling. Yeah, it's similar steps, but write them out. Go the long way. Okay. On 35, you don't want to take any shortcuts. Write out 3 of them and go about it the long way.
I did not.